Good afternoon to all of you. Shall we start?
Yes, sir. Good afternoon, sir.
Okay. See, in last lecture we discussed related to the various registers used for accessing E square PROM and program memory. Okay. So in that concern, two registers having their specific flags or bits, that is EECON 1 and 2, and these are similar. After that, remaining four are just registers which carries that respective data. That is, if it is EE data lower or higher, that is EE data, or EE DATH. Okay. So in that concern, it will consist of either lower 8-bit or higher 8-bit data contents. And in case of address accessing, that is memory address accessing, in that case, we will go with EEADR or EEADRH. So to access the 8-bit or 16-bit memory location. So these are this, we simply say that the blank registers. These registers do not contain a fixed or predefined bits, and through which we will be either set or clear that particular bit after achieving some conditions or to achieve some conditions. Okay, so this is not like that. So these four registers are used for accessing data as well as memory. Like we have seen the SBUF register in 8051, or some R0, R1 temporary registers are there, R7, like that. Okay, so these are the registers, but specific bits are not associated with these registers. So blank registers, we simply say that. Okay, so after these two registers, that is ECON 1 and 2, simply we go with the next registers, that is peripheral register, that is peripheral interrupt enable. I is again stands for interrupt enable register, and that to the peripherals interrupt. So various peripheral interrupts are there in case of PIC 16F. So to access these peripheral interrupts, we have to initially enable these interrupts, and then we are able to detect the interrupts. That like IE is interrupt enable register. So in that case, in case of 8051, we are able to define this particular interrupt is enabled or particular interrupt is disabled, like that. Okay, so here also P stands for peripheral and IE interrupt enable. There are two registers available in PIC 16F, PIE1 and PIE2. So along with that, so IE is for interrupt enabling, and for actual detection of interrupt, we will go with PIR1 and PIR2. So the bits or peripherals position are remain same. Only difference is that in IE, that is PIE register, we are able to enable or disable the particular interrupt. And in case of PIR register, we are able to detect whether the interrupt has been occurred, produced or not. So the only difference is that instead of IE, next registers carries IR. PIE converted into the PIR1 and PIR2. So in these cases, here the specific peripherals interrupt, as we see in this first register, that is PSP, AD, RC, TX, SSP, CCP1, TMR2 and TMR1. Okay, so these are the peripherals associated with the PIC 16F, and these peripherals are having the facility to enable interrupt or disable interrupt. So we are able to enable a particular interrupt like ADC interrupt. If you want only ADC, if you want receive interrupt, if you want transmit interrupt, like this. Okay, so for this purpose, we will go with first, that is enabling the interrupt, that is PI1, and then next, that is PIR1. So we see the first, that is PI, peripheral interrupt enable register. This is an 8-bit register. All 8 bits are associated with the peripheral interrupt enable bits, and all are readable as well as writable, and initial status or initially all these bits are associated with 0 level. So it is mentioned that R oblique W dash 0. So 0 is nothing but initial value or initially the position of that particular interrupt enable bits. So based on that, we will go, if we go with the first bit, that is MSB PSP, parallel slave port, read oblique write. Okay, as we have mentioned in this format itself, RW. So it will be readable as well as writable. So parallel slave port interrupt enable bit. So here, if it is 1, then enables the PSP interrupt. If it is 0, disables the PSP interrupt. So only you should keep in mind the name of that particular flag, that is PSP, parallel slave port. 0, disable, 1. Okay. Then AD, A to D converter, that is ADC. So A to D conversion completed or not. So interrupt is detected at this bit, that is ADIE. So ADIE stands for interrupt, ADC interrupt enabling bit. So if it is 0, disables the ADC interrupt, and if it is 1, detects or generated interrupt we are able to detect, that is ADC interrupt is detected if we make ADIE is equal to 1. So related to all the interrupt enable bits, initially the position is 0, that is default status is disabled, and as per the requirement of user we are able to enable a particular bit. So make 1 to the respective bit. So next, RCIE, RC for receive interrupt. Receive interrupt is enabled or receive interrupt is disabled. Here, receive interrupt in the sense of user communication, synchronous as well as asynchronous serial communication. So here, we are able to detect the receive interrupt. If you want to detect the receive interrupt, in that case, you should make RCIE is equal to 1. If you do not want to detect the receive interrupt, in that case you should make RCIE is equal to 0. Similarly, for the remaining bits, that is TX for transmission or transmit interrupt. So whether transmission interrupt, if you want to detect, in that case initially you have to enable this bit, then and then only we are able to detect the transmit interrupt, and transmit interrupt is available in the next register. Okay, so if it is 0, then disables, and if it is 1, then enables the transmit interrupt. Okay, so actual interrupts are available in PIR register, R, PIR, and enabling the interrupt is takes place in the PIE register, either 1 or either 2. So here we discuss related to the IE, so enabling the interrupts. After that, SSP, synchronous serial port. So these are the some features or architectural blocks available in the PIC16 microcontroller. So these blocks having their own peripheral interrupts. So if you undergone through the uh, architecture, so okay, so in that case we are in that the CCP, SSP, then timers, after that PSP mode is there. So all these peripherals are available in the architecture. So based on that, for that respective peripheral, one interrupt is associated in PIC microcontroller, and according to that we have to either enable or disable that particular or respective peripheral. Okay, so next one is CCP, that is CCP module is there, capture, compare or PWM sections are there, we will see later. Okay, so for that purpose, detection of that particular interrupt is takes place if we enable this bit, that is CCP1, make to the 1 or set to the 1, otherwise it is 0. Okay, if you do not require, make this bit is 0. After that, TMR2, timer 2, when we use with the period register, that is PR, in that case we will use, if we want to detect, again same formula is there, if you want to detect that particular interrupt, you should make that bit, that is TMR IE 1, and interrupt is detected as TMR 2 IF. So F is for interrupt flag and E for enable, as we have seen already. Okay, Okay. So if we consider the timer 2, then if you want to detect for each and every case, if you want to detect interrupt, then enable first in IE register and detect actual interrupt in IF, whether it is PIE1 or PIE2. Enable here, and detection is PIR1 and PIR2. Similar to the timer 1 interrupt is also there. For enabling, make 1, and for disable, make 0. If you do not want to that particular interrupt, simply make 0, or default it is 0. Edit that particular bit status only when you want that particular flag or interrupt detected. Okay. So just draw the format for PIE1 register and then write the bit status. Initially it is 0, and if you want to enable, make 1. Okay. So write for 0 and for 1, enables and disables, like that. Okay. So write down.
Completed, sir.
Okay, so after that we will go for next bits. Here TX for transmission, RC for reception. Have you completed?
No, sir, just 1 minute. Completed, sir.
Okay. So we go for further. That is in respect to this. That is when we discuss related to the enabling particular bits. So after that we go for the actual interrupt detection with the help of PIR register. So similar to the PIE, we have to draw the next register, that is actual interrupt detection register, that is PIR register. This is same case, that is 8 bits are there. So here actual interrupts are set, and if you want to clear, then you are able to clear. So these are readable as well as writable. Some of the interrupts like receive and transmit, so these are not writable interrupts. So whenever reception is completed, at that time that particular interrupt, that is RCIF, is detected or activated. So here writing or clearing the contents is not the case, because as communication is going on, and when your 8-bit data is completely received, at that time only it will activate. Okay. And same case is for related to the transmission interrupt, that is TXIF. So these two interrupts are having only read only, and we have to clear in the software itself, okay, or in your program itself. So all remaining interrupts, that is PSP, ADC interrupt, SSP, CCP1, and timer interrupts, we are able to write the contents on that interrupt also. That is either write 1, either write 0. Okay. So just draw the format for PIR1 register as similar to the PIE1 register. Instead of E, here you have to mention the F. That is, in first register, earlier register, we are enabling the bits, and here actual detection is uh, taken care out. That is, if we first analyze, so initial status of all these flags is 0. Okay, so all flags are disabled or not activated initially, but whenever that particular situation or condition occurs, happens at that time or completed, at that time that particular interrupt is activated by setting to the 1. So mention the values for 0 and for 1. So draw the format for PIR1.
Completed, sir.
Okay. So we go for next bits. This first PSP, AD, RC and TX. After that SSV, CCP and timers.
Completed, sir.
Okay, we'll see. Next is PI2 and then PIR2. So we'll take attendance first. Then we'll see what happens.